Well, today we're going to describe a soil profile, so I want to give you a little bit of a background about how do we describe soil profiles. And the first thing we need to do whenever a soil is described is to get a little appreciation of the geology, the geomorphology, the landscapes. And we're in an area in central Pennsylvania where we have what we call the Ridge and Valley Province. We have a series of limestone valleys and sandstone ridges. And then we try to get a little bit of an understanding or appreciation of the geology before we describe a soil profile. So this will help us understand what we might expect to see in this soil profile exercise. Probably parent material is one of the most important criteria that we need to understand and know before we write a soil profile description. So with that as the background, let's head to a soil profile and take a look at one. Now this soil profile was dug by a backhoe, and what happens when a backhoe or a shovel digs a pit, it smears the pit, and really it doesn't give us a very good expression of the soil horizon. So before I describe a soil, I need to go ahead and what we call face off the profile, which means really break off these smears. So I'm going to do this, and then we'll take a look at the profile after I've cleaned off the face. Let's try to describe a soil profile, and there are 6 master horizons, and in any given soil profile we may not have all 6. And I'm going to go over some of the horizons that we have in this particular soil. Now again, this is the limestone bedrock. This is what the soil developed from, so this is a residual soil. And these soil horizons developed over thousands and thousands of years to form this particular soil. Now, I'm going to go through and show you a few of the horizons, and hopefully they're pretty obvious to you. This would be an A horizon. This would be, both of these would be B horizons, and this would be the R horizon. Now you can see there's no E. You might ask, well, where's the E horizon? Remember, that's the eluvial horizon. Well, what we have here, this soil was plowed. And if there was an E horizon, it was actually mixed up in this horizon that we call an AP horizon. A, again, horizon, the surface horizon, the P indicating it was plowed. And it was plowed to this depth. Now when we start to look at a soil profile, we always start with 0 being at the top. And in this case, the depth to this profile down to the bedrock is 28 inches. So the AP is about 9 inches. The depth to this particular horizon is 9 to 17, and the last horizon here is like 17 to 28. So again, we always start using the tape in this direction, not this direction. Now, what we have here, these are both B horizons. And remember, with a B horizon, we just don't use just B, we have to have a suffix attached to it. These are subordinate horizons, so we'd have like a BT for clay accumulation, for example. And that's what this particular soil has. It has an accumulation of clay. So the clay's moved out of here into here. An eluvial horizon exits from an eluvial horizon and goes into an alluvial horizon. Now what we have here, we have a subdivision of the B. So we have a BT1 and then a BT2. And there's difference, as you can see, in these two horizons in color. There's also differences in clay content and probably in structure. Now you might say, well, where is the C horizon? Most soils have C horizons. This one, probably, if we had a C, it might be this little thin material, this weathered bedrock. But it's far too thin to call a sea horizon. We never describe horizons that are thinner than 2 inches. So if you have a horizon less than 2 inches thick, that's usually not described. So now let's take a look at some of the different features that we might look at in this soil profile. One of the first things we do when we try to describe a soil profile is to look at the different colors in the soil. And to do that, we use what's called the Munsell color system. And whenever I start to describe a soil profile, I always start with what's called the 10YR page. But if I open this page and look at this soil, I think the soil is much redder than the 10YR. So the way to do this is to get a piece of the soil out, a ped, and then compare it to the chips. And in this case, the soil is redder than the 10YR page. So I would flip to maybe the 7.5YR, or maybe even to the 5YR page, which I think this particular color of this soil falls. And then we decide on what is the value in the chroma, and this of course is discussed in one of the lessons, how to determine soil color. But at least for looking at the soil profile, I hope that you can see that there is quite a difference in color in this BT horizon. The BT1 is not as red as the BT2. When we look at soil profiles is soil structure. And I collected this right out of the AP horizon. And if you can see that this is almost like little BBs in here, and this is called granular structure. This is a type of structure that we normally see under sod. Under grasses, we have this type of granular structure. Now another type of structure we have in this soil profile is something we call blocky. And see, I just broke it out of the soil profile, and it breaks into natural peds. And these peds form something that we call blocks. I think you can see that looks pretty much like a little block. A few of these fell out, and they all tend to be pretty much blocky in shape. Now when we describe structure, we describe the size of the structure, how well developed are the structural units, and what is the shape. Is it granular? Is it blocky? Usually we call it subangular blocky because it kind of has rounded corners. It has very sharp corners, it's called angular blocky. But this would be a couple different structural types. Some of the others are like platy, prismatic. We don't particularly have those structural types in this soil. So structure, again, is an important component of the soil profile description. I'd like to point out just a couple of unique features that sometimes we see in soils, and these are features that sometimes confuse people. But right here, we have a dark feature coming down, and as you can see, it's actually material that came right out of the AP horizon. And what that is, it's probably an old animal burrow. When the animal moved down and made a burrow, A horizon material was brought down and incorporated in the B. Another very common feature we see in soils are these dark streaks here. And these streaks are actually channels from earthworms. Here's one hit here, here's another one, here's a third one. So it shows you how earthworms actually do a pretty good job of homogenizing and mixing up soil. And these are something we call earthworm middens. It's what's left behind when the earthworm goes through the soil. Now we only usually find earthworms in well-drained soils, so it's a good indication of the health of a soil if you see these earthworm channels.